Sometimes we're just given the graph of a function, and we have to work from it to generate a series of input and output pairs. So what we have in front of us is a piecewise defined function. So depending on whether we're around the boundary of x equals -2 or the boundary of x equals 4, we've got different things happening with this function. And so in the first piece here, we're asked to find what the f of 0 is. What's the output when 0 is the input? So the 0 is the x value, and so I have to figure out what the y value is on the graph. And so I go to x equals 0, that puts me on the y-axis, and so that puts me right here. So my output is therefore -3. So without any kind of equation or anything like that, I can just read this off of the graph. For f of -3, now I'm going to go over to -3, so for x, and then I move up, it looks like I've got a point right here at +3 as an output. For f of 6, so I'm going to go over to 6 along the x-axis, and so that puts me right here, so it looks like I have an output of 0. And then finally at -2, we have to note that now we're kind of at the jump from one function to the other, and so I'm going to go where the circle is filled in, because that represents where the graph is present versus the open circle, which is indicating that the graph is not at that location. Everything up to that point, but not there. So it's not this part of the graph I'm going to look to. It's going to be right here. So I'm going to have an output of -3. One feature of graphs of functions that we're almost always interested in are what we call the zeros. Those are the places where the graph crosses through the x-axis. So if it's crossing through the x-axis, that means the y-coordinate is 0, hence the name 0. So we can find those locations by using algebraic means, or we can use our graphing calculator. So we have that 0 tool that we've talked about in class. But in the case of any of these functions, what we can do is set the function equal to 0 and then solve the equation for x, and that will give us the input or inputs at which 0 is the output. So in this case here, if I want to try to factor this, I'm going to go 3x and x, because we have to multiply to make the 3x squared. We know we're going to need one positive and one negative, because we're multiplying to make a -16. And we need to add to make 22. Now it's not two numbers that multiply to make 16 and add to make 22, because this 3 is involved, so it's a little bit more complicated process for us. But as an educated guess, because I need to end up with a large positive, I'm going to guess that the positive is going to be over here away from the 3x. Because now, whatever I put in this right-hand set of parentheses over here is going to be multiplying a positive 3x as opposed to just an x, which should blow up my answer a little bit bigger. And so the factor pairs of 16, I've got 1 times 16, I've got 2 times 8, and I've got 4 times 4. Those are my only options. Now if I put a 16 over here, I'm going to blow up way too big. If I put a 4, I'm going to end up too small. But if I put an 8 here with a 2 in the other set of parentheses, I'm just right, because I'm going to end up with 3x times 8 is 24x, and then I have a -2x, which will give me my 22x that I'm supposed to end up with in the middle. So with that, I'm going to take each of these sets of parentheses and set them equal to 0, and then solve. So I add 2 and divide by 3, so I'm going to end up with 2/3 out of this first answer, and then x plus 8, if I subtract 8 from both sides, I'm going to get -8 as my second result. The next one is a rational function, so I again can set it equal to 0 and then go about solving. But one thing that we should take note of is that the zeros of a rational function are always just the zeros of the numerator. So essentially I can just ignore the denominator, set the numerator equal to 0, and for a rational function that will give me the zeros, the place where the graph crosses through the x-axis. And so if I add 2 to both sides, I get x equals 2 as my answer. the case of the last one, I can again set my equation equal to 0 and set about solving. So we need to isolate the square root and then square both sides. So I'm going to add 4 to both sides. So I've got 8x plus 4 equals positive 4. Now I'm going to square both sides. So I get 8x plus 4 as that square and that square root cancel each other out, equals 16. If I subtract 4 from both sides, I'm going to get 8x equals 12. If I divide both sides by 8, I get x equals 3/2. So we solved all of these through algebraic means, but again, we just as easily could have solved using a calculator and that zero tool. So depending on which model you're using for the inspires, after you've graphed the function y equals whatever the function is, you go to the menu, hit Analyze Graph, and then you can find the zero tool and then find it that way. On the 84s and 83s, we're going to graph the function, and then we're going to go to the Calc menu and then find the zero tool there, and then just follow the step-by-step guide to get us to the zeros.